I'm Anil Kumar. Welcome to my series on trigonometry. Here is another multiple choice question which you can find in many interesting test papers for advanced mathematics. Given tan A equals to 0.75, find exact value of sine A by 2. Four options are given to you. Now, some of you might know the formulas for double angle and half angle. You could use those formulas and solve this particular question, right? But here is something which I want to share with you, which is, I think, a unique or very interesting way of solving this question. So we are looking into one of the best ways of solving the given question. We have tan A as equal to 0.75. If I write it in fraction, we get 3 over 4, right? 3 quarters. Okay, 3 over 4. So that means that in quadrant 1, if I have opposite side of 3 and this base, so let's say that's my point. So in that case, the triangle here with an angle, let's call this point as A now, with this angle A, we have the sides in the ratio of 3 to 4. So this is 3 and this side is 4. So now we know tan A, this angle is A for us. Let me write here, that is better. So tan of A is 3 over 4. We need to find half angle. So the trick is something like this. If I use Pythagorean theorem, I can find the hypotenuse, which is 3 square plus 4 square square root, which is definitely 5, as you know. And if I construct a line here, which is of the same length as 5, let's say this is 5 units, right? Maybe minus you this side. Okay, doesn't matter, since we made a coordinate plane. So we have this side as 5. Let me call this point here as B. So we have a point P and Q here, and I mark a point P. With this point B, I'm connecting point P. So I have another triangle. So if I connect this, right, in that case, what is the angle right here? Interesting. What is this angle? Well, we know something, that these two angles are equal. So we know that angle PBA is definitely equal to angle BPA, right? Since the two sides are equal, so we have isosceles triangle. Perfect. Now, since it is an isosceles triangle, these two angles are equal. But we also know from external angle that angle A is actually equal to sum of these two, right? Is equal to angle PBA plus angle BPA, right? So that means, and these two are same, right? So which is equals to twice angle PBA. Perfect. So in that case, this angle is equal to A by 2, right? So what we finally get from here is that A by 2 is the value of the angle PBA, right? Dividing by 2. So that is the measurement of these angles which we are getting. So we know this is A by 2. Now this problem becomes very simple. Since we have a right triangle to work with, whose sides are known, we know this is 5 units, this is 4 units. So total of this side is 9 units, correct? And this is 3. So now BP is going to be 9 square plus 3 square square root, which is 81 plus 9 square root, which is square root of 90, which is 3 square root 10. Is it okay? So we get this side which is equal to 3 square root 10. Do you see that? Now we know that BP equals to 3 square root 10, and we know PQ is 3. So what is tan of oh sorry, we want to find sine, right? We want sine A. So sometimes it could be cosine or tan, right? So sine of A by 2 will be opposite side, which is 3, over the hypotenuse, which is 3 square root 10. 3 and 3 cancel. So what you get here is 1 over square root 10. Option C is the right option. Do you get the idea? So without using calculator, we are in a position to solve this very easily. Now I had to only explain you exterior theorem and all those things, but generally you know all this, correct? So once you could have an idea that an isosceles triangle can be created, external angle is half of the sum. External angle is sum of the two remote interior angles. And since they are equal in isosceles triangle, that angle is going to be half of this, right? And that helps us to get the solution. And that is how we get it. I hope you understand and appreciate the steps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that will be great. Thanks for watching and all the best.